Hey, this is Scott. Hope things are going well. Say, I've got a lot of questions this chapter about um, the, the variations, both joint variations and inverse variations from sections 8.2 and 8.3 in this unit. First of all, I want to say thank you for asking those questions because sometimes especially in online mode, you don't know what you should be covering more of or less of or anything else like that. So I appreciate you folks asking the questions. So like what I want to do is I want to run through a couple of these, because really what they end up being is like two-step problems in solving some of these pieces, and want to make sure that you folks feel comfortable with that too. And so we'll take a look at a joint variation or a direct joint variation, and then an inverse one, and then a combined one, and so you can feel good with that, because like I said, they end up being kind of like two-step problems here with all that. So first one I want to take a look at, and I think this is problem number 11 on your homework for this week. If p varies jointly as the square of x and the cube of r, and p equals 108 when q equals 3 and r equals 2, please find p when q equals 4 and r equals 3. Well, first thing is when you're looking at variations. And we're going to look at a joint one here to start with. Basically, you're going to have some p equals some constant k times some x times some y, whatever that case may be. And so once again, as these numbers go up, p will go up. And so that's kind of how these are all combined here together. In the case of question number 11, p, our number out front here, we don't know our k constant. It says varies jointly as the square of q, so the square of q, and the cube of r. Okay, and we're going to talk a little bit about squares and cubes here in chapter 12 with that. But that's what it's saying. And it says when p is equal to 108, still don't know our constant, and when q is 3 and r is 2. Okay, so we know that this is what we've got here. So we've got 108 equals q times 3 squared is 9 and 2 cubed is 8. Okay, and so then we have to go ahead and we multiply this out, so we get 108 still is equal to 72k. All right, now we need to divide each side by 72. And when we do that, what do we get? Oh yeah, I think it is. You're right. I think it is 1.5 with that. So we get k to equal to be 1.5. Okay, so now that's our constant. Now we have to go back and plug that into, just a touch here, plug that back into our original equation here, right here, this one. Okay, and so we're trying to find p now when we know our constant k is 1.5 times, and I think it says that q now this time is 4 squared and r is 3 cubed. Okay, so I just took those numbers. Now I know my constant, which is k, and then my p and my r again, my q and my r again, I plug those into that equation, and so now I get p is equal to 1.5 times 16 and times 27. And with that one, I'm going to pull out my handy dandy calculator here and see what I can figure out that to be. I do know that 16 times 1.5 is going to give me 24. However, I don't think I'm going to try and multiply 24 and 27 in my head tonight. But we do get an answer of 648. So P in this case is equal to 648. Now, I'm really hoping that's the correct answer as I go to look these pieces up. But I'm thinking that should be, unless I did something really goofily wrong with all that. So, but those are some of the pieces that that work with a joint variation. Okay. All right. Okay. I also want to, I'm multiplying something out here real quick, make sure I'm correct here too. Times 24 times 27. Yeah, 648. That's what I thought. Okay. I also want to look at an inverse one and then a combined one too with all that. So I'm going to go, let's see here. That's a whole new page here. Solve using proportions. I'm on page 372. Actually, I'm gonna get a new page here too for us. So insert. All right, so I'm back here at the top here. I'm actually on page 372 in section 8.3 now. Oops. Sorry about that. Section 8.3 page and looking for a good problem here now with an indirect variation with that. Some of these are just proportions. Well, how many days? Can't find one I like. Okay, well, I'm just going to kind of apologize for the. Well, here let's take a look here at 13, 14, and the next one's there with all that too. Trying to find a good one here. Those are just more ratios with all that. I think I'm just going to jump over to combine one and show you how the inverse one works on that one, because that's the only one I'm seeing really good, a good example of what I'm looking for here with that. Question 31, and this is actually going to be on page 373 now. It says in a relationship P varies directly as M and inversely as N, and the constant of variation is 18. Okay, so what that is saying, it says, remember we're going to have P equals some constant, and it says it varies directly as M, so directly is going to be in the numerator, and inversely as N, so N goes in the denominator. So P equals Km over N. And so as we go ahead and plug our numbers in here in number 31, it says the constant of variation is 18, and we know M is 14, and N is 28. And so then we would just multiply that out to find out what P is. But the big thing here is we have our K, our constant, is right here. That's K. And this piece right here, this blue piece, in this case is the part that is the one where it varies directly. That's the one that varies directly. And then here we'll have our green one. This is the one where you varies indirectly. Okay, that's one that varies indirectly. So once again, we just multiply that out to get our answer, and I got a sneaky feeling we probably could reduce this down and get pretty close to numbers we like working with. So we're just going to do that here just because we can. Okay, so I know 7 goes into there 4 times. I know 7 goes in there twice. All right, 2 goes into there once. 2 goes into there twice. Probably could have just reduced 14 and 28, made my life easier, but I didn't see that. 2 goes into here once. 2 goes in here 9 times. So my answer, as I reduce all this down, is P is equal to 9 when I multiply all that out. Let's take a look at another one while we're on a roll here. We'll do one that's a little bit harder than with all that. Okay, let's go to Let's go to 35, then we'll finish off with a really fun one. Okay, A, this is question 35 now. Question 35. Okay. And in this one it says A varies directly as the square of B. Okay, so we always have our constant. It varies directly as the square of B. And I lost it. And inversely with C. So we know we have C right there. Remember, this is our direct part up here, our indirect part down there. And it says now, and A is equal to 5,000. When B is equal to 40. That's a K there too, by the way, for our constant. And C is equal to 8. Oh, that was rotten. I'm going to erase that. Hold on. Sorry about that, folks. Okay, so we're going to go back here. 5,000. So I have K, and it says B is 40. And C is 8. Okay, and then it wants to find out what the constant is in this case. So in this case then, as we go to solve this, okay, we have 5,000 plus K times 1,600 divided by 8. Oops. I'll put my K back there. Okay, now if I divide this out, I have 5,000 equals 200K, because 1,600 divided by 8 is going to give me 200. And now when I divide each side here by I'm going to divide each side by 200 here. I'm going to get K is equal to, zeros cancel out. Actually, let's do it the right way. 100 goes into here twice, 100 goes into here 50 times. 2 goes in there once, 225. So the constant in this case, K, is going to be 25. Okay. So once again, direct and indirect. Direct is in the numerator, indirect is in the denominator. I do want to take a look at one more. Because I know someone asked me a question on this one too, and I don't know. I think this may show up on your assignment somewhere too, or something similar to this with all that. Oh, I need another page to work on here. Oops. That's not right. Oh, help me days. Okay. So in looking at this one, I want to look at one more here. Page 37, because this one's got a couple steps to it. It says a horizontal beam safely supports a load P that varies jointly as the product of the width of the beam and the square of the depth of the beam and the length, and inversely as the length L. Oh, and by the way, this is on page 373. Page 373, question number 37. Okay. Okay. So what we need to do here is, first of all, it says that the load P that varies jointly as the product of the, we got our K all the time, remember on this, we have our K, varies product of the width W of the beam and the square of the depth of the beam. So the square of the depth squared. This is where it varies jointly with that. And inversely as the length. So inversely as the length. So all that's over L, because that's inversely as the length. Now it says a beam that has width of 5 and the depth of 12 and a length of 8 can safely hold 1,260 pounds. Okay. And so then it says determine the safe load if the beam made from the same in pounds of a beam made of this from the same material if the beam is 20 inches long. So in this case, the length is 8, and we want to know what it would be if it was 20. Okay. So first of all, it's inversely, so you would figure as the length goes up, the amount that it will hold will go down. So eventually we're going to probably get an answer that is smaller than our 1260. But the first thing we have to do to figure that out is we got to figure out what K is here. So let's go ahead and do that. So let's multiply that out. We got 1,260 on this side. We're going to have K times 5 times 12 squared is 144 all over 8. Okay, so we got 1,260 equals, and I think 5 times 144, that 144 is going to be 720. So we have K is 720 over 8. And I bet if I divide that out, I'm going to get 9 for an answer. D, yeah, that's what I said, 9D. So I get 1,260 equals 90K. And then, of course, we divide each side by 90 to get our answer. So I got 1,260 divided by 90. And what do I get? 14. Cool. All right. Nice numbers to work with here. So I get K equal to a value of 14. Now, we have to go back and plug this into the information that we know. Because what it's saying now in the rest of the question, this is just part of it. And it says he wants to know the amount of pounds it will hold if everything is the same except the beam is 20 inches long instead of 8 inches long. So basically, everything is the same. And we will replace that 8 with 20. And now also we know K is to be 14. So we'll go back down here. And so I'll say it's 14 times 5 times 12 squared. I should have my parentheses in there, sorry. And we are going to divide this all by 20 now instead of 8, because that's what it asks us about here. So let's go ahead and multiply this out here. Oopsie, that's not what I wanted to do. So as I multiply this out, first thing I have to do is I have to take 14 times 5 times 12 squared. And I get 10,080. So I get P is 10,080 divided by 20. I get an answer of 500. Whoops. It was 504. And I think our label on this is pounds. Oh, rather, those deals. 504 pounds. Okay. And that's just like we talked about before. We're working with the inverse side of this. So as our length here went up to 20, like we talked about, as our length went up to 20 here, we expected our answer to go down because they're inversely related that way. So anyway, that's a little bit more in inverse and joint variations. I hope that helps a little bit more for you too. Once again, I apologize for not covering this a little bit better in the initial videos. But like I mentioned too, I appreciate those of you who ask questions, because I know if in this case we had 3-4 of you asking questions, so I'm sure there's more of you out there too with those things. So please feel free to ask questions to make sure that we're getting you on the right track with some of those things too. So anyway, if you do have any more questions on this, please ask, and I'll do my best to get you pointed in the right direction with some of those things. So 38 is another one you can do, because it's working with the same type of problem as we did here, and so you should be all set with that. So like I said, give me a holler if you have any questions. I'd be happy to help you. I think I'm around the office most of the day the next 2 days. Oh, the other thing with that too is, like I mentioned in the announcements piece, I scooched back the due date of this assignment because there were so many questions and I wanted to get more information out there on it. So even if you had submitted it, I reopened it up again so you can go back in and fix anything you maybe had wrong, or if you didn't understand, or whatever the case may be with that too. In addition, because there's a couple days longer where you can work on this assignment, I did move back the due date of the test one day also. So anyway, if you have any questions, please make sure you ask, and I hope you're having a great day. We'll talk to you later. Bye.